Launching a satellite or spacecraft to the moon involves multiple steps, from launch to landing and returning to Earth. Here's a detailed breakdown of the process. Steps for sending a satellite or spacecraft to the moon. 1. Launch from Earth. Rocket launch. The spacecraft is placed on a powerful rocket, which propels it beyond Earth's atmosphere. The rocket has multiple stages, with the first stage providing the initial boost to escape Earth's gravitational pull. 2. Translunar injection, TLI, trajectory setting. After reaching Earth's orbit, the spacecraft is given an additional boost called a translunar injection. This sets it on a path toward the moon. 3. Cruise phase to the moon, coasting through space. The spacecraft follows a precise trajectory toward the moon, coasting through space, relying on the moon's gravitational pull to guide it closer. 4. Lunar orbiting phase. 5. Descent to the lunar surface. Controlled descent. Once in lunar orbit, the lander, a separate module in some missions, separates from the main spacecraft. It uses thrusters to gradually descend to the surface, ensuring a soft landing. Landing on the moon. The lander must carefully navigate the moon's uneven surface and ensure a precise, slow descent for a safe landing. Steps for returning to Earth from the moon. 6. Needs enough fuel to escape the moon's gravity and return to lunar orbit. 7. Rendezvous in lunar orbit, docking with orbiter. The ascent module meets the orbiting spacecraft in lunar orbit, docking with it for the return journey to Earth. 8. Trans-Earth injection. Journey back to Earth. The spacecraft fires its engines again to set a trajectory toward Earth. This is similar to the TLI maneuver, but in reverse, with Earth as the destination. 9. Re-entry into Earth's atmosphere. Atmospheric re-entry. As the spacecraft approaches Earth, it enters the atmosphere at high speed. Heat shields protect it from the intense heat caused by friction with the atmosphere. 10. Splashdown or landing. Safe landing. The spacecraft deploys parachutes to slow its descent, landing either in the ocean or on land, where recovery teams will retrieve it. Top 10 considerations for a successful moon landing mission. 1. Accurate trajectory planning. Careful calculation of the translunar injection and re-entry paths is critical for conserving fuel and ensuring the spacecraft reaches its intended destination. 2. Fuel efficiency and propulsion. Enough fuel must be available for all stages of the mission: the initial launch, translunar injection, lunar landing, and return to Earth. 3. Thermal protection. Spacecraft must be equipped with heat shields to handle the intense heat during re-entry into Earth's atmosphere. 4. Communication systems. Maintaining a continuous line of communication between the spacecraft and mission control is essential for receiving commands and sending data back to Earth. 5. Landing site selection. Choosing a flat, stable area for landing on the moon reduces the risk of landing in dangerous terrain like craters or rocky regions. 6. Navigation and guidance systems. The spacecraft must be equipped with precise navigation tools, including gyroscopes and star trackers, to ensure accurate control during the mission. 7. Redundancy in critical systems. Backup systems must be in place for life support, power, navigation, and communications in case of failure during any part of the mission. 8. Radiation protection. Spacecraft need to be shielded against solar and cosmic radiation, which can damage electronics and pose health risks to astronauts. 9. Lunar surface operations. Robotic systems or astronauts must be prepared for surface operations, whether conducting scientific research or setting up infrastructure. 10. Safe return procedures. Ensuring a successful re-entry and landing on Earth is critical. This includes having precise re-entry angles, parachute systems, and recovery plans. These factors need to be carefully managed to ensure the spacecraft's successful journey to and from the moon. As of 2024, several missions have successfully reached the moon, either by orbiting, landing, or crash landing on its surface. Here's a breakdown of the notable lunar missions. Key satellites and spacecraft that reached the moon. 1. Luna Program, Soviet Union. Luna 1, 1959. The first spacecraft to reach the moon, though it missed its target and became the first artificial object to orbit the sun. Luna 2, 1959. the first human-made object to crash land on the moon. Luna 9, 1966, the first successful soft landing on the moon, transmitting panoramic images of the lunar surface. Luna 10, 1966, the first spacecraft to orbit the moon. 2. Apollo program, USA, Apollo 11, 1969, the first human landing on the moon with astronauts Neil Armstrong and Buzz Aldrin walking on the lunar surface. Apollo 12, 1969, the second human lunar landing. Apollo 14, 1971, the third successful human landing, with Alan Shepard use a lunar rover. Apollo 16, 1972, the fifth crewed lunar landing. Apollo 17, 1972, the final crewed mission to the moon. 3. Ranger program, USA, Ranger 7, 1964, the first successful U.S. spacecraft to transmit close-up images of the moon before crashing into its surface. 4. Surveyor program. Surveyor 1, 1966, the first U.S. spacecraft to make a successful soft landing missions. 5. Clementine, USA, 1994, a joint mission with the Department of Defense. Clementine mapped the lunar surface and provided valuable data on lunar minerals. 6. Lunar Prospector, USA, 1998. This mission mapped the composition of the moon's surface and found evidence of water ice at the lunar poles. 7. SMART 1, European Space Agency, 2003. The European Space Agency's first mission to the moon. It orbited the moon and studied its surface using a variety of instruments. 8. Kaguya, Japan, 2007. Also known as Selene, this Japanese mission orbited the moon, producing detailed maps and 3D models of Chang'e program, China. Chang'e 1, 2007, China's first moon orbiter. Chang'e 3, 2013. Successfully landed a rover, U-2, on the moon, the first soft landing since 1976. Chang'e 4, 2019, the first spacecraft to land on the far side of the moon. Chang'e 5, 2020, successfully returned lunar samples to Earth. 11. Lunar Reconnaissance Orbiter, LRO, USA, 2009. NASA's LRO is still operational and has provided high-resolution maps of the moon's surface, including the landing sites of previous missions. 12. Artemis 1, USA, 2022. The first uncrewed mission in NASA's Artemis program. It was a test flight to pave the way for future human missions to the moon. 13. Chandrayaan 2, India, 2019. While the orbiter was successful, the lander, Vikram, failed to make a soft landing. The orbiter continues to send valuable data. 14. Luna 25, Russia, 2023, intended to be Russia's first moon landing since the Soviet era. Luna 25 unfortunately crash-landed on the moon's surface. 15. Chandrayaan 3, India, 2023, successfully landed on the moon near the South Pole, making India the first country to achieve a landing near this region. Summary of major lunar missions: USA, NASA, Apollo, Surveyor, Ranger, LRO, Artemis 1. Soviet Union, Russia, Luna program. China, Chang'e program. India, Chandrayaan program. Japan, Kaguya, Selene. Europe, SMART 1. These missions have advanced our understanding of the moon and laid the groundwork for future lunar exploration, including potential human settlements. Reaching the moon requires overcoming significant challenges in terms of distance, speed, and energy. Here's a breakdown of the key details. Distance to the moon. Average distance. The average distance from Earth to the moon is about 384,400 kilometers, 238,855 miles. This distance varies slightly due to the elliptical shape of the moon's orbit. Speed of a rocket to reach the moon. Escape velocity needs to reach a speed of about 11.2 kilometers per second, 40,200 kilometers per hour, or 25,000 miles per hour. This is called escape velocity. Speed during flight to the moon. After the rocket escapes Earth's atmosphere, it slows down a bit, but still travels at an average speed of about 7 to 10 kilometers per second, 25,200 to 36,000 kilometers per hour, or 15,600 to 22,500 miles per hour, journeying to the moon, using thrusters to ensure a soft landing, often bringing the speed down to a few kilometers per hour before touching the surface. Time taken to reach the moon. Typical duration: A spacecraft typically takes around 3 days, 72 hours to reach the moon, depending on the mission profile and trajectory. How much energy and fuel is needed? The amount of fuel depends on the size of the spacecraft and the rocket used. Missions to the moon typically involve a multi-stage rocket with enough fuel for different phases of the journey. First stage provides the initial thrust to leave Earth's atmosphere. Second stage gives an additional boost to enter orbit and initiate translunar injection, TLI. Ending. After reaching lunar orbit, additional fuel is needed to slow down and land safely on the moon. Example of fuel requirement. For instance, the Apollo missions used the Saturn V rocket, which weighed over 2,900 tons. Most of that weight was fuel. The fuel used was a combination of liquid oxygen and liquid hydrogen for maximum efficiency. Cost of lunar missions. The cost of reaching the moon depends on many factors, including technology, mission type, and objectives. Here's an estimate based on some past and current missions. Apollo program, 1960s to 1970s. The entire program cost around $25.4 billion, equivalent to over $150 billion today adjusted for inflation. Recent moon missions. Chandrayaan-3, India, 2023. Estimated cost was around very cost-effective. Artemis program, USA, ongoing. NASA's current Artemis program is projected to cost tens of billions of dollars over several years, with each launch costing about $4 billion. Key factors affecting the cost. 1. Rocket size and payload. Larger rockets and heavier payloads increase fuel and cost. 2. Mission complexity. Manned missions, like Apollo, are much more expensive than robotic missions, like Chandrayaan. 3. Technological advancements. Modern missions often benefit from more efficient technology, reducing costs compared to earlier missions. 4. International cooperation. Costs can be reduced through partnerships, such as ESA's contributions to NASA's Artemis program. Reaching the moon is a costly and challenging endeavor, but advancements in space technology are making it increasingly accessible. Step humanity should take after landing on the moon. Should we focus on building a lunar base or push towards reaching Mars? Why?